Welcome, and our topic today is centered on time series, and to be more specific, we are going to look at one of the models that are normally used in analyzing the seasonal variations, that is the multiplicative model. The other model being additive model. We shall look at it in our next lesson. Now, when we talk about the additive model, we talk about a model that factors in some components of the trend series or the trend seasons. We talk about components of the seasonal variations and components of the random variations. In other words, is a type of a model that actually looks into these particular variations which are dependent on each other. And to be more elaborate on that, it is used in analyzing seasonal variations by computing the average seasonal index. So actually we are going to look at how do we get to an average seasonal index using the steps here. And we have a question from our CASNEB June 2011 that was done in June 2011. The question is talking about, we are given the sales for 3 years, 2018, 2009 and 2010, and each year having 4 quarters, 1, 2, 3, and the sales are given in thousand, or of course in millions, sorry. Then we are required to compute the center 4 quarter moving averages. Of course we are going to do that one, but if you want more, we shall look at one of the videos that I've actually linked in the description below. Then we shall look at the average seasonal index of each quarter using the multiplicative method. Now I've just copy pasted the question. We have the year, the quarters, and the sales for each year. I've just copy pasted in this case, so you can as well do away with the paper. And to be more specific, we are going to look at how to compute a 4-centered moving average. Before that one, we shall look at computing the trend values. That is the first step in our question, that is T. And computing the trend value, we shall first of all compute the uncentered 4-quarter moving average. After that, we shall talk about now the element to do with the centered quarter moving average. Now, how do we get the uncentered quarter moving average? Remember, a 4-centered quarter moving average is normally a step of 2. We talk about the uncentered and the centered one. And when you talking about the 4 quarters moving average, we are normally focusing on the next quarter. In other words, the first quarter will normally not be focused in any given seasonal variation model. So we talk about this one. When you talk about the uncentered 4-quarter moving average, we shall sum these first 4, and then when you add 16 plus 34 plus 24 plus 12 and divide by 4 because there are 4 items, you get a value of 21.5. So 21.5 should actually be written in this particular case. You do the same for the next seasons, that is from 34, then you cover 4 quarters again that way, add the 4, divide by 4, you get a value of 23.5. If you do the same to that one, you shall do for this one, we shall do for this 4th one now, then you shall do for this particular, then you shall have this one, shall have these 4, then finally we normally have that. Of course, we shall have this one also. All the way. Then of course when you compute the next 4, we shall have an average of 25.0. The next 4 again should now be this one here. All the way to this one should be an average of 27.5. Then if you go next to an average or to a value to do with these particular items here, divide by 4 should be a value of 29.0. Then the next items, that are this one all the way to 4, should be 31.0. Add these 4 again, divide by 4 should have a value of 35.0. Again add these 4, divide by 4 should have a value of 39.0. Then lastly, you should have this one here. This one was a mistake, should not be there. We have 32 all the way to the last 4 quarters, because when we add this one, there is no other one to add it to here. So we shall have 32 all the way to 28. If we add this 4 divided by 4, we have a value of 41.5. Of course, these last two cannot be focused. And then we do now we have uncentered. In a 4 quarter we talk about the first 4 sets, then we talk about now the next 2. Like you're going to have now the average of these first 2. Remember now in this case you cannot focus this one, then we focus for the next quarter, which is the 3rd quarter. Of course the other quarter again cannot be focused automatically. We normally focus for the next season. Sorry. So when you add these 2 divided by 2, we shall have a value of 22.5. Add these 2 again, divided by 2, we have a value of 24.25. Again you add this, we have that one, so we have that, we have now this one to that, should have a value of 26.25. Then we have now the value of that one to this, should have a value of 28.25. Then you have 20, this one 2 divided by 2 should be 30.0. Add this 2 divided by 2 should have a value of 33.0. Add this 2 divided by 2 should have a value of 37.0. Then lastly, divide by 2, we have a value of 40.25. Then now we compute the seasonal index by actually dividing the y, which are the sales, versus the centered moving quarter, the centered 4 quarter moving average. And in this case we have, for example, we shall now talk about now the seasonal index as per where the values are. So we will not have these two. We talk about 24 divided by 22.5, we get a value of 1.07 and you round off. Again 12 divided by 24.25, you have a value of 0.49 rounded off. Divide by this, you get a value of 0.91. Divide by this, should have a value of 1.42. Sorry, 34 divided by 30 should be a value of 1.13. 18 divided by 33 should have a value of 0.4, 0.54. Then this one divided by this should have a value of 0.86, and lastly divided by this should have a value of 1.39. Now, after this, we are done with what is known as the computation of the trend values. So our new trend values are this one, and then of course we have now computed again the seasonal index. So our trend values are T, Roman 1, then Roman 2. The next step we compute the seasonal index. That is what we've actually done by dividing the actual values, the sale versus the time trend. We can now go ahead and compute the average seasonal index by actually finding the sum of the means, that is step 3, and then comparing if the sum of the mean is equal to the number of seasons. Like in this case, our number of seasons per year is 1, 2, 3, 4, 1, 2, 3, 4 for each year. So if the sum of the means will not be equal to the number of the seasons, which is 4, we shall do the adjustment factor. So how do we get the sum of the means or the seasonal index per year? We simply have this particular working in this case, like we shall have now. Of course, we shall have the year, under the year we shall have now the quarters, quarter 1, quarter 2, quarter 3, of course quarter 4 for each and every year. So 2008, the first quarter, the seasonal index is, there's no seasonal index for quarter 1 and quarter 2 because we can never predict that particular variations. We talk about quarter 3 and quarter 4, these two. So we have 1.07 and 0.49. Then 2009, we have the seasonal index for all the quarters. We have 0.91, we have 1.42, we have 1.13, then 1.54. Then the last year, which is 2010, for the first quarter is 0.86, 1.39. Of course, the last quarter there is none for these last quarters. So after that, we shall now talk about, now for us to get the sum of the means, we shall first of all get their sum and then get the average of those means. So sum of the means will actually be this one. We now get the total of those means. Like in this case, when you add these two, we get 1.77. Add these two, we get a value of 2.82. Add these two, you get a value of 2.20. Then add this and you get a value of 1.03. So how do we get the average seasonal index? For us to get now the average seasonal index, to see whether it is equal to the number of seasons, after adding all of them, then we shall have our last average seasonal index at that particular case. So we divide this one by 2. We divide this one by 2 because there are 2 elements here. Divide by 2, you get a value of 0.885. Divide this one by 2, you get a value of 1.41. Divide this one by 2. It is this one was 2.81, should be 1.405. and then this one should give you a value of 1.1.10. Then of course when you divide by 2, because there are 2, we get a value of 0.515. 0.515. And then you're told if the sum is not, you get the sum of the mean. So we are going to get the sum of the means first. Let us add and see what comes. You shall get their total here, the sum of these means. So when you have 0.885 plus 1.405 plus 1.1 plus, no sorry, it is 1.1 plus 0.515, we get 3.905. So we know that 3.905 is not equal to the number of seasons, which is 4. Don't round off, because actually the slight difference here is what brings the variation that we are trying to talk about, or we are trying to focus. Then what does the last step says? If the sum is not equal to the number of seasons, like in this case, adjust them as follows. So we have the adjustment factor. How do we get the adjustment factor? Therefore we talk about what is known as the adjustment factor, which should now be sum of the seasons in this case, which is 3.905 divided by number of seasons per year. We have 4 seasons, so the answer divided by 4, we get 0.97625. So this adjustment factor that we are talking about, where will you apply it? Now these average seasons that we had, we are going to divide each average seasons by the adjustment factor to get the adjusted average seasonal index. So we can simply have, of course we can bring them down here. So we still have 0.885, shall have 0.405, this one here. We have 1.10, and then 0.515. We divide each by the adjustment factor 0.97625, 0.97625, 0.97625, then 0.97625. So the first one should be 0.885 divided by the answer should be, when you round off, should have a value of 0.907. So this one is the adjusted now. Adjusted means this is the final, because we have talked about the adjustment factor. So we have the adjusted average seasonal index, away from now the normal seasonal index. Then 1.404 divided by 0.97625. When you get to this place, don't round off. So we have 1.439. We can round off the answer to 3 decimal places. Then we talk about the next one, which is 1.1 divided by 0.97625. We get 1.127, round off to 3 decimal place. Then you have the last one, 0.515 divided by 97625, we have a value of 0.52728 rounded off to one decimal place. So we have actually answered our question by computing the centered 4-quarter moving average and getting the average seasonal index of each quarter. That is using the multiplicative model. Then now, a question can arise whereby you are now told to deseasonalize the profit. Remember, these sales, they generate some profits, and these profits depend on some element of variations that are going to come in. So how do we actually deseasonal the profit? We talk about now each sales which will generate the profit divided by the average seasonal index for each and every quarter. Like 16 divide by this one here, 0.907. This one should be 32 now. The second one should be now be 34 for second quarter, divided by 1.439. That is the seasonal index for the second quarter. Then the fourth one should be 24 divided by 1.127. Then the last one should be 12 divided by this one, 0.528. You get the answers which are going to be computed. I want you to compute the answers for me kindly, so they can be able to follow that procedure. Then you have 24 for the next one. I just want to show you 24 divided by the same, 0.907. Second quarter we have 40 divided by this one, 1.439. We have 34 divided by 1.127. And then lastly we have 18 divided by 0.528. You do the same for the next quarter. Like we have this one here, should now be 32 divided by 0.907. Then 56 divided by it's for the second quarter should be 1.439. 50 divided by 1.127. And then lastly we have 28 divided by 0.528. So compute the answers, you get those will be the deseasonalized profits. So these profits that you're going to arrive at after working this one means the effect of season variations has been removed from them, and therefore they can have some smooth element of prediction. Thank you very much, and please don't forget to subscribe if you find this video helpful.